connect to the stream. Hold on. Ariana, can you hear me?
Yeah, I can now.
All right, great. It's my internet right now. I don't. And yeah, okay, there. I think everything's okay now. All right. So,
Oh shoot, everything's glitching. Hold on. Sorry. The thing is, I mean, I'm looking back at the problems right now, and it's
mm-hmm.
like I have to like do some weird thing. Hold on.
All right.
Let's pull it up. Oh gosh. Wait. You know what? Hold on.
Okay.
It's a. Hold on. I have to grab something. I'm back.
Okay, great.
Uh, I kind of just. I am kind of confused on mainly how to get the like which part goes to where for like the exponent stuff
Mm-hmm. The
for
exponent.
specifically for like the word problems.
Can you give me like a specific one so I kind of get what you're trying to figure out here?
Um, can maybe like 5.
Okay, let's go to number 5. Okay, I'll go straight there. All right. So here, let's just take a look at this problem first. So you have a new computer,
Mhm.
costs $1,500, and it depreciates by about 0.18 per year. Okay. So write an equation that would indicate the value of the computer after X years. How much will your computer be worth in 6? And how long will it take for your computer to be close to $0 according to the equation? About how long, right? Okay. All right.
Did
Uh,
you make a new? Did you make a new board?
oh yes, I did. Sorry, I forgot that.
Did
Let
you make a new
me.
board?
Yeah, I did. So let me give you the new link.
Hmm.
Oh yeah,
Okay.
I made a new one last time, didn't I? But anyway, it's fine. Let me share that with you right now.
Yeah.
Okay. All right. So while we're you do have access to the question. So what one thing we will do here is I'll just discuss this briefly while I wait for the thing to load here. Ah, never mind. I'll share it here. Easier.
Okay.
All right. Link has been shared. Hopefully, yeah, link's been shared with you, so you can access that. Okay. So first of all,
Hmm.
okay. Before we go here, let's kind of go to the whole idea again. Okay. So whenever you have an exponential function,
All right.
whether it's a growth or decay function, it will always be equal to something raised to the power of x, right? Okay.
Hmm.
Now, the way I would normally think about this to make it a bit easier is a lot of the time, problems involving growth or decay involve the concept of time, right? So this is the general form,
Hmm.
but I would normally think of this as f of t equals a raised to t if we're talking about time.
Okay.
This, for me, this makes it a
Hmm.
little bit easier to understand how to properly process the equation. Say hi.
Hmm.
Okay.
Hi. Oh wait.
I
Hold
know
on.
my kid's here. My kid's here.
Oh okay. Hi.
All right. Can Okay, hold on. Say hi again.
I'm, I'm scared.
All right. Okay. Okay. Let me have my lesson now, huh?
Okay, bye.
Bye bye. All right. Let's go back. So if
Mhm.
whenever I do it like this makes it easier for me to see which one is which. Okay. Another thing that you would normally see here is for to make it a bit easier to remember is uh what happens when t equals 0, right?
Mhm.
The main thing that happens here is that at t equals 0 you have your initial amount, so f of t is in the initial amount.
Mhm.
Okay. So normally, I'm going to change this a little bit, the equation, because normally we don't normally see these in actual equations. We normally see something like, I'm going to give this a capital A, then times some value R raised to X. This is actually the more general form, okay?
Mhm.
So this would be A R raised to T, okay? So if you
Mhm.
put T equals 0 in there, then your A is what? That's going to be the initial amount, right?
Oh, okay.
Okay. So this means f at t equals 0. Let me just rewrite this part. F at t equals 0 is the initial amount, and that's equal to A. All right.
Mhm.
So that's the second thing. So again, first thing is you try to think of this in terms of time, and time is the one that um, determines how much your amount increases or decreases, right? And then the second part is
Mhm.
this other number here is going to be always the initial amount. The rest of
Oh.
this, the rest of this will come in depending on the equation. Okay.
Mhm.
All right. So let's take a look at number 5 right away. Let's go look at this question right away now. Okay. So
Mhm.
first of all, let's identify the numbers. You have an initial amount. This is
Okay.
your initial amount, right?
Mhm.
So this would be your A. Okay. And then
Yep.
this is how much it decreases per year.
Mhm.
Per year, right? Okay.
Yep.
So in other words, it says here per year, so our time will be in terms of years. So this is t.
Mm.
Okay. So let's just put a function now. What's the function? F of x. I will use t to make it a bit easier. F of t is equal
All
to
right.
what?
A R T
R.
or
Yeah.
um. Can I write
Yeah. Go ahead.
1 5? That's a 5. 0
Mm-hmm.
0. Um. R is 18. Oh no, zero
No.
point. Yeah.
No. It's not quite.
Okay.
All right. I'll tell you this much now. Okay.
Okay.
R is usually 1 plus or minus that value, whatever this value is.
Mm.
Okay, now again, this is normally the case in problems when you, especially
Mhm.
when you're talking about a percentage, right? So
Okay.
when you see the percentage sign, that's what you do.
Mhm.
Okay, so in other words, what do you do
So
here?
it's
1 minus, it depreciates, it should be minus.
oh.
All right, yeah, so if it's depreciate, so it's minus. If it appreciates, if it increases every year, it's gonna be plus.
Mhm.
Okay, then
Mhm.
all right, and then
And then
your t is going to be just t.
the year
Mm-hmm.
T.
Yeah, that's it.
Mm.
All right. So before we go to B, I'm gonna look for a similar problem here. You try to do the exact same thing we did here. Okay. I think we have
Okay.
one here. Number 3, similar.
3.
Uh huh.
Okay. So I have to write the equation.
Yep.
F of T
Mm-hmm.
equals 800.
Right?
I know. 1. This would be plus, right?
Correct. It's plus because it's growing.
Okay. 0.05
Mm-hmm.
t.
Yep. Correct. Done. Okay.
Okay.
Okay. I think it's quite obvious now, right? So
Mhm.
in this case, number two is we're gonna reverse this later for number two, but the idea is still gonna be the
Okay.
same. All right. Oops. Sorry, I shouldn't have done that.
Okay.
Okay. Did I change anything? No. Good. All right. So let's go back to five here. So how much will your computer be worth in 6 years? So in this
All right,
case,
there it is.
yeah. How much will the computer be
Would you
worth in
make
equals? Okay. I got disconnected, I guess, or you got disconnected. All right. I lost your audio back
Ooh,
there for a while.
I'm still here.
Okay.
Oh.
All right. So far, correct.
Um so would change t to 6. Yeah?
Yeah. Yeah. Correct. Oh, okay. One last thing. I just want to make
Okay.
sure that this is because it already said X years here. We need to change our letter to X. Yeah. But either way, it should be fine. In fact, once you have this, you can
Same
actually
thing.
just, yeah, same thing. Anyway, you can do a shortcut here right away and just say this is 0.82 straight away.
Okay.
Okay. But anyway, yeah, put that in the calculator, get the
Mhm.
value, and done.
All right, I'll get my value.
Mm-hmm. Where is my calculator? Those two.
456.01.
Well, it's a price, so it should be enough, right?
Yep.
Yep. Okay. So 456 $456 and 1 cent. Correct. Okay.
You.
All right. Let's go to C. How long will it take
Hmm?
before the computer is worth $0? Zero
According
dollars.
to the. Mm.
Okay. What do you do in this case? This, remember the f of x is the price.
Mhm.
All right. So,
So we change that to 0.
mm-hmm, exactly. You change your f of x to 0. So again, this means f of x equals 0.
I'll
This
make
one's
that
a,
one with more.
yeah, this one is a bit
Oh, wait,
tricky.
delete just text. Plain.
Mm-hmm. This one is a little bit tricky because if you really want to do this properly and
It's not.
find x, your answer should be infinity.
Oh,
Should
trick
be.
question.
Uh, yeah, but think about it this way. In these particular cases, you want to get an answer that's reasonably close to 0, right?
Mhm.
Uh, what's a number in terms of price that's reasonably close to 0? It should be less than 1 cent, right?
Yeah.
Yeah. So in this case, I'm going to rewrite that to be reasonably close to 0. Okay. That should be
Mhm.
less than 0.01. That's a reasonably close
Mhm.
0 value, right?
All right.
So you can use that value in here.
Mhm.
Okay. Now, how do you find t? You just do logarithms in this case, I think.
Yeah. Wait, huh?
Hmm. All right, hold on. Let me scroll up a bit. There.
E.
New one.
0.
Mm-hmm. Mm-hmm.
Mhm.
Okay. So what's the next step?
Um, I don't know.
Okay. You don't know. All right, fine. The next step here is to get the logarithms of both. You can use either the natural logarithm or you can use log base 10. So you can do this and then do the same thing here. Or you can do this 6.6 times 10 to the minus 6 that equals ln of 0.82 raised to t. Okay. Now, you can do this. All right, but I'm going to focus on the log base 10. Okay. Now, I'll
Mhm.
say before we continue, just so we're clear, at your level, you're expected to use this logarithm, but once you
Mhm.
get to DP, you're expected to use this more often. Okay?
Okay.
But either way is correct. Okay?
Mhm.
So, the idea here is once let me zoom in so we have some room to work with. Okay. The idea now is once you set this up, this logarithm of 6.6 times 10 to the minus 6, you can calculate that straight away, right? So on the
Mhm.
calculator, I'm just going to that's going to give me uh, negative 5.176. Okay. Now,
Mhm.
here, what happens here is there's a rule in logarithms. Remember that logarithm of a raised to b is the same as saying b logarithm of a, whatever
Mhm.
the base is. Okay.
Okay.
So in this case, what's going to happen here is this is going to become t logarithm of 0.82. Okay. Now,
Mhm.
if we calculate that now, 0.82, take the logarithm of that. Uh, which did I use? Base 10. So logarithm. This is going to give us, so, so negative 5.176 is equal to t times negative 0.0861, 62.
Yep, I
0.
got that too.
All right, so great. 0.0862. All right, and then finally we just find t.
Mhm.
Okay.
So then you would just divide the 0.082
Mm-hmm.
by
That's
the
correct.
5.
That's correct. So uh, then we'll multiply that by
60 years.
5.176. That gives you 60 years. Yes.
21.
T, which in the lifetime of the laptop is basically infinity because afterward you don't actually use a laptop after like 10 years unless
Yeah,
it's really get taken it's well taken care of.
really good taken care of, yeah.
Mm-hmm. All right, so the idea here still correct, yeah.
Mhm.
All right, okay, so let's go back to the beetle problem because again this is going to be a similar question. So how many beetles will there be in 8 months?
In 8 months. So would I have to like change the X into like kind of make it into like years in a way?
No, no, you don't have to. The idea here is you look at the time in the problem. They must be the same
Mm.
units of time. If units of time are the
Okay.
same, you don't need to convert.
Mhm. 800 1 plus 0.05
Okay,
8.
correct.
Oh,
Okay.
That's a lot of beetles.
Mm-hmm. It's gonna be a lot of beetles.
Rounded.
Mm-hmm. Okay. I would round that off to 1181, not 82. Okay. Why
Mm-hmm.
is that the case? Because you can't have a portion of a beetle. No matter how close it
Ah.
is to one beetle, it's not yet a whole beetle, right?
Mm-hmm.
Okay, so, or in fact, because it's just an estimate, you can actually also say 1180. Yeah, either way should be fine. Yeah, right? I think I think you
Yeah.
got the hang of it now.
Yeah.
Right, great.
I'm just not a big fan of word problems.
Mm-hmm. So, okay, actually, these would be the more difficult versions. Okay, let's go here to number two. All right, so going back to what we meant, so let's take a look. We don't even let's just do number 2A now.
Mm-hmm.
Okay, so remember before we continue here, remember that your f of x, in this case it's y, right? F of x is equal to
Mm-hmm.
a 1 plus r or minus r raised to x, right? That's always the equation.
Mm-hmm.
So what is RA and what is our R and what do they mean?
Mm-hmm. So the 720,500
Mm-hmm.
is the initial amount.
Okay, initial amount. But in this case, our initial amount, there is a time mentioned here.
Mm-hmm.
So this would be the, okay, let's,
Uh, eh,
right. It is the initial amount, but in terms of the problem, what is this initial amount? Okay, let's look here. Remember that in this problem, it says X is the number of years since January of 1980.
mm-hmm.
So in other words, your initial time is January 1980. That's where you start.
Oh.
Okay. And
Mm-hmm.
how much and what is this number? This number exactly would be the population of the city, right?
Oh, the population. Oh,
It's
the
right there.
initial population.
The initial population, or you can say the population of Brownville
Mm-hmm.
on January 1980.
Yeah.
Okay.
Yeah.
Okay.
Do I have to write that?
Yeah, I'll do that for you. No worries. Okay. So this will be the
Alright.
population of Brownville
Mm-hmm.
at January 1980. That's what
Mm-hmm.
that is. Okay. What is this?
Um, it's the rate that it's growing.
It's growing exactly, but
Mm-hmm.
uh the population is growing by how much? Or what's the growth
Zero.
rate?
I mean, 2.2%.
Correct.
Yeah, because the one is
Yeah.
there.
You have
Because you
to.
have to add the one.
Yes, exactly. All right. Exactly. This the answer now. Okay. I think this one's more
Yay!
obvious to you. This one is still
Mm-hmm.
needs a bit of practice, but I think you got it now. Yeah.
Yeah, because I I was like reading it. I'm just like, huh,
Mm-hmm.
assuming.
Uh-huh. All right. So let's answer B now. What would the population be in 2000? What was the population if the growth rate continues at the same rate?
So I have to minus 2,000 from 1980 first,
Correct.
right?
Correct. So your time here would be 20 years.
20.
Right.
So it would. So X would be 20.
All right.
Oh,
Okay.
we both wrote it.
Just go ahead. I'll zoom in a bit so you can
So
have a bit more space to operate.
all right.
Mm-hmm.
And
All right, so that's correct.
that's a big number.
Uh-huh.
1, 1, 1, 3, 4, 0, 1.
Okay, correct.
1 million.
Yeah, so you grew from 720,500 to a million. Okay,
Mm-hmm. Yay!
correct. Use this model to predict about when the population will first reach a million. So in this case, what are you changing now?
Why?
Y. Yes, correct. You're changing Y here.
Okay.
And find T.
You're gonna add the commas.
Mm-hmm. Okay, let me zoom in again for more breathing room. Mm-hmm. Correct. Raise to.
And I'm making that T.
Okay, you want. Okay, go ahead.
So be 1 million divided by 720,500. Right?
Correct.
So 1, 2, 3, 8, 8
Mm-hmm.
equals the 1.022, and then you log that.
Uh-huh. To T. So you
Okay.
take the logarithm of both sides, correct? Again, either one, either base 10 log or natural logarithm will work. But you have to use the same one in either side. Don't use log on
Okay.
one side and then natural log on the other side. Okay?
I'm just using what the
Base 10.
log button
Yeah.
on my
Yeah.
calculator.
That's the more obvious one to use. So go ahead, just use that.
Yep.
Mm-hmm.
0.0945. And T goes there now.
That's correct.
And then you divide it. Yeah.
Mm-hmm. That's correct.
15 years.
15 years. So 15 years. So when did it happen?
Okay, so 1995.
Correct. All right. So this
Uh,
is 1995. All right, great. So that's okay. You're really getting the hang of this now, so we're good. Okay,
yeah.
number two, number
hmm
three done. We have two more to go, number four and number six. Let's just do number four
hmm
now.
And I'm pretty sure number one is pretty easy. It's just like if it shows growth or decay.
Yeah.
Okay. I want to try this by myself.
Oh, interesting. Yeah, just try to. It's the same techniques, but the interesting bit here is that your t is t over two. Your time here is t over two, or the exponent
Ooh.
rather. Right?
Mm-hmm.
Now, having said that, it's still the same way to solve it. To solve for t as you would. Okay.
Mm-hmm. So at 200 milligrams, so I'm guessing that's going to be M.
Mm-hmm.
A dosage of Advil takes at 1 p.m. How many milligrams of medication will remain in the body at 6? So
Mm-hmm.
0.5.
Mm-hmm.
So that time span between each other is just like 5. So it would be
Right.
5 divided by 2.
Correct.
And then we're going to find R. Yep.
Correct. Correct.
Mm-hmm. So 200, 0.5. I got 35.4 mg.
Mm, correct.
Okay.
Great. Okay. How about this next one?
The B.
Mm-hmm.
If 200 milligrams of dosage of Advil takes about how many milligrams of medication will remain in the body after 12 hours?
Okay. Uh-huh.
So it'll be still 200 here, 0.5, and then 12, 2, which can simplify to
Mm-hmm.
6
Right.
because I don't like fractions in my
Okay.
thing.
Mm-hmm.
3.125
Correct.
mg. Yay!
Milligrams. Uh, it milligrams. All right. Correct. So that's pretty fast. So let's just finish this now. We have number 6.
Mm-hmm.
Okay. So you invest $10,000 in an account with that much interest, compounded quarterly. Okay.
Quarterly.
Yeah, quarterly. So assume you don't touch the money or add money other than the interest earned. Okay, write an equation to
Mm-hmm.
use the amount of money Y in the account after X years. Oh, this is gonna be a bit trickier because of the fact that it
Okay.
says here quarterly, but it says here years, right?
Mm-hmm.
Mm-hmm.
So y or f of
Okay,
x
right.
using
Let's use
y.
Y here.
Okay, 100,000.
Correct.
So that looks like a one. One. Oh,
Mm-hmm.
plus. Yeah,
Correct.
plus
Interest. So yes, plus.
0.0. Wait, 101.
Mm-hmm. Correct.
Um, quarterly compound. So you get your thing quarterly.
Uh-huh. So how many interest periods do you have in a year? Because of that.
4.
4. Okay. So you have
So
to multiply your exponent by 4 in this case.
okay, so x times 4.
Mm-hmm.
That it?
That's it.
Okay.
Okay, that's it. All right. So now that you have your equation, let me go through the equation again. Why is this x times 4? Because this is quarterly, and this
Mm-hmm.
means there are 4 quarters in 1 year. Okay,
Mm-hmm.
so that's why there's the 4 there. Okay,
All right.
and then this x here would be years.
Mm-hmm.
Okay, if we were talking quarters though, we don't have to do the multiplication by 4 anymore. Okay.
Ah.
All right.
Mm-hmm.
So having said that, let's continue. Let's go to B. How much money
Mm-hmm.
will you have in the account after 10 years and then after 25?
Okay. Is there a way I can just copy and paste this?
Yep. Go ahead. Oh, let me
I'll
zoom in
just.
again a bit.
I can't pick up stuff. Okay. I'll just rewrite everything. Okay. So 10 years.
Mm-hmm. Right.
1, 2, 3. 1 plus 0.0101. 4 times 10. Around 1, 4, 9,
Mm-hmm.
4, 7, 7.16. Yeah.
Okay. Um, Let me calculate that real quick.
Mm-hmm.
Just to be sure. That's gonna be 1. 1.01, hold on. 1.0101 raised to 10 years would be 40. Raised to 40 would be that much times 100,000. Okay. Your answer is correct. 477 dollars and 16 cents. Correct.
16.
All right.
Yay!
All right. Next one. How about 25 years?
Mm-hmm. Okay, I'll just replace the
Mm-hmm.
the 10 with a 20.
Right.
5.
25 becomes
7, 3, 1, 7, 2.58.
correct. So both are correct.
Yay!
All right. Great. So Ariana, we have around 10 minutes left. Would you like to do one,
Mm-hmm.
or would you like me to give you another problem? Like I make one on the spot.
Try and make one up on the spot.
All right.
Because I think one I could just I think it's I just write down either if it's growth or decay.
Right. Okay.
Right?
All right.
Yeah.
Hold on. I'll try to type that in.
Okay.
Okay. Let me think. Let me think. What's a common one? Okay. A car dip. Better change colors. Change that to black. I'll just delete that. Okay, here. A car value dip appreciates at 8% per year. Okay. Its current price. Okay, I'll make it a bit more difficult. Okay. Its current
Mm-hmm.
price is, let's just say $2,000. Where's dollars? $2,000. The car was bought brand new. Uh, let's say 12 years ago. Okay. So the question now is, uh, first again is write the equation as come of the price of car as a function of time. Time t. Write the equation for the price y of the car as a function of time t. And then the second one is what was the original price of the car when bought. Okay. Right. I think that's good
Mm-hmm.
enough as a problem. Let's make this bigger.
Yeah.
Okay. And when was, no, 12 years ago. Okay.
Mm-hmm. So the equation is y. Let me stick again.
Mm-hmm.
Equals 2,000
Mm-hmm.
1 minus
Uh-huh.
0.08, right?
Almost right. Don't forget the
Okay.
exponent t. Don't forget the exponent t, right?
Oh yeah, yeah, yeah.
Okay. Now, this
T.
is okay. I'm gonna say this now. This is not right because in this case, this is the current price. This is the
Oh.
right. That's a 2000. But here's the thing: it was bought 12 years
Oh,
ago.
so wait. That would 2000 would be why?
If we're talking about now, yes. But generally, you would just say this to be
Oh.
some original price. I'm gonna say P for now. Okay, where
Okay.
P is the original
So it would
price.
be 2000. Mhm.
Okay, now,
Okay.
all right, correct. So where would
So
you
it'd
put
be
2000?
equals A or P. I like P.
Mm-hmm.
1 minus 0.08. And then T would be 12, correct?
Correct. Correct.
Oh, okay. Okay, okay. Yeah.
Okay.
And then, so then we just kind of calculate that in the Z calculator.
Mm-hmm.
1 minus, oh shoot, earlier turned off. 1 minus 0.08. Wait.
Okay. Correct. Correct so far. So what's the
Um,
final answer?
439.71.
Okay. Let me just do that. 0. I'll do that in the calculator real quick. 0.92
Mm-hmm.
exponent to 8. No, not 8. 12 is that much. Then you take the inverse. It's 2000. Okay, correct. 4000. So this is correct. Okay, great. Now, okay, I'll just verify this now. Just
Mm.
so we're clear, yeah? The answer to the first one is y is equal to p times 1 minus
Yeah.
0.08 raised to t, where p is the original price of the car. Okay, so that's the first part.
Mm-hmm.
The second part is where you substitute y equals 2000.
Mm-hmm.
Y equals 2000, and that's equal
Mm.
to p raised to 1 minus 0.08 raised to 12. Okay. All right. So just so we're clear, how to properly write the answers
Mm-hmm.
here. Right. Ariana, here's the deal. We have 5 more
Okay.
minutes. You wanna just use those 5 minutes answering one, and then we can end for today.
Mm-hmm.
Okay. Let's do one then, real
Yeah.
quick.
Okay. Yeah.
Just just write G and D. G for growth, D for decay.
All right. And like
Mm-hmm.
decay is we're like let's see. Decay is not if it's only decimal. It has to like be lesser than one only, right?
Uh-huh. Yeah.
Or
It has to be less than one.
okay. So okay. I just wanted to make sure because I got like that
Mm-hmm.
wrong during like the homework. Just like, huh? So,
Mm-hmm.
um, this would be growth. Yeah. Then.
C would be growth. Yes, C is growth. All right. How about okay, C, this
Because
is
it's a
D,
okay.
this is E, this is F.
Decay.
Decay is correct.
Um, growth.
Okay, because of the plus growth, correct?
Okay. And this one, decay.
Okay, why is F decay? That's correct.
I
Because
don't think
of
it
because of that the minus. Okay.
because one because it's because
Mm-hmm.
yes, so it wouldn't make it negative 1.4. It would make it 0.6.
Correct. Correct.
Yeah.
All right. It's great. So that's I think you got the hang of it now. So okay, on to the next one for next time. Yeah.
Oh whoa.
All right. Don't worry about it.
Yeah.
Just undo
Oh
that.
shoot! I accidentally moved
Just undo that. It's fine. Or I
thing.
can move it myself.
It's not letting me undo. It's not letting me
I'll do
undo.
it.
It's
I got it.
undoing.
I got it.
Okay.
There
Thank you.
we go.
Sorry.
No problem. Here. There. Okay, that's good enough. All right, so we'll
Yeah.
end it
Are we
here.
gonna move to a new board next time?
Remind me not to, but if I do, I'll share the link again. Yeah. All right. Anyway, either way, at this point we're good.
All
So,
right. Okay.
all right. So I'll see you again next week. Just have a good day. I'll see you then. All
You
right. Bye.
too.
All
Bye
right. Bye.
bye.
All right. Bye, Arno. See you. Let's do that here. All right. So that's the end of the lesson. So for those who are joining the stream, thank you for joining. Nobody actually joined the stream today, but it's fine. Um, so again, that's just one way to that's basically the way of how to deal with exponential functions, whether it's growth or decay. Right. So um right, so I hope that everything here is clear and I'll end the stream today. So before we do though, don't forget to like, share, and subscribe to the channels. We're on YouTube, Facebook, TikTok, Instagram, and Twitch. Yes, all Twitch. And just follow those names as you see on the screen. So again, don't forget to share, subscribe, and of course, like the videos. With that, this is the end of today's session. So uh, thank you all for listening, and with that, I bid you all a good morning, good day, good afternoon, good evening, good night, wherever you are in the world. Stay freaky, everyone. Bye bye now.